All right, everybody. So welcome again to another Operator Framework SIG meeting. Lots has been happening, and lots more will be happening over the coming weeks and months. So we're definitely into hearing your feedback on the operators that have been written and the status of things that you're working on. Have a bit of an agenda here as people show up. We'll put them on the stage, so my agenda might not be in the perfect order. Rob, I'm going to ask if you can kick us off with a bit of an update on operatorhub.io and intro. I think you were planning on doing that, so I'll let you go with that. And if you can share your screen, if you have anything, I'll pop over there for now.
Awesome. Yeah, nothing really to show. Well, I guess I'll show the actual website. Why not?
So cool, and we're so happy to have it.
Yeah. Okay. Since we've last met, we launched operatorhub.io, and this is what that looks like, with a number of really great operators in it that work with the operator lifecycle manager, and have been tested on various upstream Kubernetes providers and things like that. And so would love everyone to go here, check out some of these operators, list your own operators. There's some instructions here at the top under the contribute link for submitting your operator. And what this does is, render a bunch of cool information about your operator, its capability level, some of the versions, if you've got multiple versions, things like that. And so we've seen a lot of success with this. We got some pretty good press coverage, and we're seeing a lot of traffic to it. So would love to encourage everybody to get their operators listed, and so that all the great Kubernetes users out there can find it and use it. That was basically all I had. Nothing too crazy. Other than we've also seen a few major updates to these operators, which is great. I think the Federation operator just landed a really big change yesterday with some really great docs improvements and a new version of that. And so this is another great aspect of operatorhub.io, which is you have this conduit to communicate changes to folks so that they can install those and get those new features, new security updates, whatever they are.
I think the Strimzy one was updated recently to the latest release of Strimzy Kafka. The Planet Scales, the test one was just recently updated as well. So the update process seems to be working pretty good, and we've got a couple of other pull requests coming in. Some for operators I'd never heard of before. So it's gaining some nice traction, and people are giving us some good feedback. And definitely, if you have feedback on it, let us know, or make a pull request against, especially the docs. If there's something missing, let me know, and we'll try and get that updated too. So, thanks for that.
Yeah, and we've got, like you mentioned, we've got some PRs waiting in the wings. I think for some folks that are demoing today, like StorageOS has a PR open, and there's some other. There's a Spark operator from Google that is in PR, and some things from SysDig, their monitoring product, as well as Falco, the anomaly detection tool. So a lot of good stuff coming as well, and we'd love to see more.
Yeah, well, the one just floated by this morning from a Micro Rocks. So now I'm going to go look at their API and all that good stuff. So yeah, it's coming, it's happening. And we're really pleased that you're all participating. So thank you very much. So let's see who we have here. I think we have StorageOS. So we'll move the IBM Andre Tost to the end. And how about Simon, if you take over the screen share and kick us off with an update on your StorageOS operator story.
Sure. Okay. Let me know when you can see my screen.
Yep.
Yeah, okay, great. So I don't know how many people are familiar with StorageOS. I'll just give like 1 minute of that. So we're a software-defined storage product, essentially designed for running applications like databases within containers. So we scale out, we run as a container, typically on every node in the cluster. any storage capacity that our container can see will aggregate and represent out as virtual volumes. And we do things like replication, encryption, and all the typical sorts of enterprise type features. But importantly, we're block storage, so it's designed for performance in mind. So we've been working on operators for a while now. We've definitely seen the how operators can make it easy for users to not only install the product but the day two management. As with, I guess, most operator demos you'll see, there's probably not a lot to see, because a lot of the good stuff in an operator is hidden in the background. That's the knowledge that we build into the operator. So I have installed the StorageOS operator in this cluster, and typically you'd only run one instance of StorageOS across your Kubernetes cluster. So we do have a few different CRDs. So one for the cluster itself, another for kicking off an upgrade. So a lot of the benefit of the operator is actually in this upgrade process, which lets us hide all the complexity of a rolling upgrade from the end user, and allows us to do a non-disruptive upgrade totally hands-free. The StorageOS job is just for various maintenance tasks, like cleanup after an uninstall, where we want to completely remove StorageOS from the system. So if I go in and create a cluster, so I've already created a secret. I think this is quite normal. You have to pre-create a secret. Create that. So in the background, this will go and set up all of our resources, basically a daemon set, the service, and some other bits, and eventually that will come back and you'll have a fully running StorageOS cluster. So that usually takes about a minute to come up. One of the things we'd like to do upcoming is add a few more options in the UI for configuring the cluster once it's up and running. So things like taking nodes offline, or changing the log level, things like that. So once this cluster comes up, it'll be fully usable, and there's not a lot more to it than that. We've implemented, much like the etcd operator, when the cluster comes up, it'll show a pie chart of the available node, what their status. But I'm not sure if you want to sit around and wait for that. So I did write up some sort of lessons learned. So it wasn't me that wrote a lot of this. It was a guy called Sunny, who I think is on the call. But I've mentioned some of the reasons why we went the operator route. So a lot of it is hiding complexity from end users. So, for example, we can decide whether to install StorageOS as a CSI or non-CSI, depending on the orchestrator version, or what distribution it is. With the upgrades, we could just do the right thing without having to write a lot of complicated documentation and guiding users through that. A few things that we've sort of come across that maybe caught us off guard are with the garbage collector. We decided not to rely on that for the cluster CRD. We do create, especially when encryption is enabled, we allow users to store some of the encryption keys as secrets. So obviously we don't want to delete all of their encryption keys when we delete the namespace. So we take care of those ourselves. Another thing was, this is more of a question to anybody who's more familiar with it. We would like to use pod priority classes, especially the system node critical. Essentially we never want the storage system to get evicted from a node, but that requires us installing in the kube system namespace. So I'm kind of interested in what the thoughts from community are on that, whether that's acceptable. And I guess a bit on where we're going, we're looking at implementing a node controller just to give it better visibility into the state of the Kubernetes cluster, and that will help us make better data and pod placement decisions. And finally, one thing that we really appreciated was the testing framework that's available within the operator SDK. If I just sort of flip over to if I go to our operator is open source and on GitHub. If I go, for example, to our Travis, it's just really easy to set up end-to-end tests on a variety of different. So I want to refresh that. No. So I think that's kind of all I had. I wasn't going to give a demo of the product because you're probably more interested in the operator. So.
At this juncture, you definitely get you to give us a demo of StorageOS at some later date too, though.
Yeah. Okay. Is there anything else I can add to that? So.
I would love to hear how you're using the testing framework, like kind of what your thought is for exactly what you were testing inside of that and that kind of thing.
Okay, I would probably need to get Sunny to go into a bit more detail on that, but all of our tests are on the GitHub repo. Yeah, so yeah.
Hi, I am here, Sunny. Can you hear me?
Yes, we can.
Okay, so we deploy the cluster and we check if the daemon set and stateful sets are healthy, and if we have any, like, we have a node controller, so we test if when we update the node labels in Kubernetes, it's updated in our StorageOS labels as well. It's like small tests, all are written in Go. That's small kind of things, yeah.
Okay, awesome.
Cool.
Another question that I'd like to ask. Usually when we see operators managing the version of handled within the custom resource or the primary custom resource, that is usually not a additional upgrade CR that triggers an update. I wondered what was the compelling event that motivated you to kind of separate that and not just have code executed based on changing a version field in the spec.
Yeah, I mean, because other pods running on a node will be dependent on the volumes that are presented by the StorageOS container, we want to make sure that, we don't want to stop the StorageOS container at a bad time. So we want to control that upgrade process. So essentially that lets us, in the background, before we upgrade a node, we can create a new replica, we can migrate data across, we can move pods around so that we can make sure that we don't take an application offline.
Sure. I guess my question was more towards the actual interface to trigger an update. So why have like a separate CR for that versus making it triggered by updating a spec in the StorageOS CR itself?
I can answer it. So we have a really big process of upgrading. We have a separate controller for upgrade, which goes through different steps. Like it changes the replica count of all the applications and updates the daemon set with the new image and checks the health. Once everything is up, it reverts all the changes it made, and it takes the StorageOS, the whole system, out of the maintenance mode, and it restores everything. So there is a lot happening which we cannot do in the same controller. So we have a separate CRE for that.
Gotcha. Thanks.
Right. Is that everything on that topic? Thanks very much for that update. And now I think the next people up, I think, are the Portworx folks with their Stork operator.
Great. Thank you. So
there you go. A little bit louder if you could. You're very quiet.
okay, I think it's my mic problem. Hopefully this is a little bit better.
Yes.
We have a couple folks here from Portworx, and we just wanted to start off this with a quick, setting the stage. We are in the same space as StorageOS, so that's great that they are also here today. So today we are going to quickly talk about Stork, which is our storage operator runtime for Kubernetes. So there's a couple of us here today. So I'm Vick Kelkar. I'm on the product side, and we also have Dinesh, who is sharing his screen and the presentation. So I will quickly walk through and set the stage of what Portworx is all about. And then I will hand it over to Dinesh to talk about the operator implementation and do a little bit more technical deep dive and a demo. So we are a cloud native data platform. So we not only do the normal, activities related to storage, so virtualize and present it as different pools of storage for the applications. But then we also work with different schedulers, so Kubernetes, OpenShift, and others. We are also application aware, so it allows the developers to kind of take a look at not only the application lifecycle, and the storage operator is kind of helping the developer do self-service. So that's a very high-level overview of Portworx platform. I do wanted to kind of highlight that we have certified our container image of our product, and it's already in the OpenShift Red Hat registry, and we are working on getting our operator certified and pushed into Operator Hub. So we are actively working on that, and I just wanted to set the stage, and I'm going to turn it over to Dinesh to now talk about the Stork operator. So over
hey guys,
to you.
can you hear me fine?
Yep, loud and clear.
Okay, cool. So Stork basically stands for Storage Operator Runtime for Kubernetes, and the goal for writing this was basically to provide additional intelligence for storage solutions in Kubernetes, because we found that there are some things that Kubernetes can't do natively, like provide hyperconvergence, and initially it couldn't take snapshots and provide some other app consistent stuff that we wanted to basically do. So Stork is an open source project, and there's a GitHub link present over here. We had also written a blog detailing with some more technical details on how some of the things work within Stork. So you guys can take a look at that after the presentation if you want. So I'll just go over the high level details of the features that we have in Stork. So we provide hyperconvergence by using a Kubernetes scheduler extender so that it prioritizes nodes where data is located. Then we also do additional health monitoring for pods, so that you can actually have uptime, more uptime for your stateful applications. Then we also have support for volume snapshots based on the Kubernetes incubator project. Apart from that, we've also added CRDs for basically taking group volume snapshots and also taking application consistent snapshots. So you can actually run pre and post exec commands before and after you want to take a snapshot, so that you can either quiesce or flush data to the disk before taking snapshots. And the latest operators that we've added in Stork are basically around pairing clusters and migrating data between two Kubernetes clusters. So this actually migrates your data as well as your Kubernetes resources between clusters. And this is useful for cases where you want to do like blue-green deployments, or you have a dev and production environment where you basically want to migrate your workloads from. And then we've also written a small tool called StockCurl to basically help manage the resources more easily, because if you just use kubectl with CRDs, they don't give a lot of information. So StockCurl basically helps you get more information and manage them better. So I'm just going to walk through some of the CRDs that we've actually created. So this is these are some of the first CRDs that we've created. So we basically have a rule CRD that can be used to run commands when you're taking snapshots or group snapshots. So I've shown examples of how you would do this for MySQL. In this rule, you would basically log the MySQL tables, take a snapshot, and then basically unlock the table. For Cassandra, you can do stuff like you can make sure that all the data is flushed to the disk before you actually take a snapshot. So basically, once you define these rules, you can then refer to these rules from a snapshot or a group snapshot CRD. So on the right side, if you see, I've just defined a group snapshot CRD, and I've specified that in the Cassandra namespace, I want to basically take a group snapshot of all PVCs with the label app Cassandra. And before running it, I just want to run the Cassandra rule to make sure that all data is flushed to the disk. So some of the latest CRDs that we've added are around cluster pairing and migration. What you can do in this is basically you can specify how you want to connect to a storage system on another cluster as well as Kubernetes on another cluster. So there are basically two parts in this spec. The options part basically has the IP token and the port for the storage cluster, and the config part basically has what you would specify in your kube config on how to connect to another cluster. So I'll be going through a demo of the cluster pairing and migration, and I can show you how the specs would actually, the entire spec would look like. But over here you can see this is just an example of what my remote clusters API server would look like. You would then have your different credentials and certificate data in this CRD. And once you basically specify a cluster pair, you can then start migrating data between the clusters. So for example, this is the migration CRD. And in this, you would basically have a reference to the cluster pair that you created in the left side. And you would basically say that you want to, there are a couple of options. So you can go through whether you want to include resources, whether you want to start the applications once you migrate them, and you can specify the list of namespaces that you want to migrate. And some of the other CRDs that we are working on are basically around scheduling things. So for stuff like snapshots and migrations, you basically want to be able to schedule them regularly so that you don't have to trigger them manually all the time. So again, we've defined CRDs for all of this. So you can specify a schedule policy to say when things should be triggered. So you can have them at intervals, then you can specify you want to trigger them daily, weekly, or monthly. And once you specify these schedule policies, you can basically refer to them from different types of schedules. For example, you can have a snapshot schedule saying that you want to basically take a snapshot every minute, and you would basically specify that in the schedule policy name over here. In the snapshot schedule, you would basically then just have a template for the actual snapshot spec over here. So this is basically saying I want to take a snapshot of the MySQL data PVC every depending on how the test policy has been configured. And you can basically use the same thing in the same policy in a migration schedule too. So again, over here, the spec is basically a template from the migration spec, and you can specify the same options over here as well as the schedule policy that you want the migration to be triggered on. So what I'm going to do now is I'm going to switch to my terminal and show you a demo of how the migration CRD works. So start from here and all right, can you guys see my screen?
Yes, we can.
So what I'm going to do is I'm basically, so I have two clusters deployed over here on the left. If run kubectl get nodes, you'll see I have the three worker nodes and a master node. And if I do the same thing here, yeah, I have three different worker nodes here. What I'm going to do is I'm basically going to deploy MySQL on my source cluster. Then I'm basically going to pair it with my remote cluster, which is the cluster running on the right. And then I'm going to run the migration CRD to basically migrate the MySQL app from cluster 1 to cluster 2. So I'm just going to show you the MySQL spec. And over here, as I mentioned, we've implemented a scheduler extender to provide hyperconvergence, right? So all you need to do is basically in your specs, set the scheduler name as Stork. And at that point, it will basically talk to Stork to figure out where the data lies for the PVCs and basically prefer scheduling those pods closer to the PVCs. So I'm just going to apply this. Let's just wait for the pods to be running. While this is happening, let me just show you how the cluster pair spec would look like. So this is how you would have a cluster pair. So there's a lot of information that needs to be transferred from the, not a lot of information, but basically some information about the kube config that needs to be transferred from the destination to the source and then formatted. So we've actually provided Stork commands to do this. So you can actually run a command to basically generate a template for this. So if you do this, it actually spits, if you run, so let me show you what the command was. So it's basically, you can run Stork generate cluster pair, give it the namespace that the spec should be created and the name of the spec, and this would basically spit out a template. And then you would basically just have to add the storage options into the spec, and then you can copy it to your source and apply it. So this is one of the specs, one of the templates that I've generated over here. And as you can see, I set up the IP of the storage node on the other cluster, just one of the nodes, and a token that I generated from the storage cluster and the port that our API server is running on. So let me make sure that this is up. Now that this is up, I'm just going to apply the cluster pair that we saw. And again, I'm going to use Stork to look at the status. So as you can see over here, the storage status is ready and the scheduler status is ready. This basically means that we were able to pair with the scheduler on the other side as well as the storage on the other side. If you want, we can look at the YAML, and over here in the YAML, it actually has the storage, the cluster ID for the remote storage ID, and it actually has the status for both the scheduler and the storage. So now once we have the clusters paired up, we can start migrating applications between them. So based on what I showed you as an example, this is how we would migrate MySQL. So I'm just going to point to the remote cluster that we just paired with, and I'm going to say I want to migrate volumes as well as the resources. And once the resources are migrated, I basically want to start them up. So before we start this, what I'm going to do is I'm going to start a watch over here on the MySQL namespace. And as you can see, there are no resources over here right now. And what I'm going to do is I'm going to just apply this spec. So you can actually use kubectl, Stork to start the migrations too. There are subcommands to do that. Yeah. And now that we've applied it, I'm just going to use Stork to watch. And as you can see, so what's going to happen is first it's going to start migrating the volumes that are used by the applications in the MySQL namespace, and then it's going to start migrating the resources. So here, as you can see right now, it's in the process of migrating the volumes. Once this is done, this is going to go into the application stage, and once that's done, it's going to go into final stage, and it's going to give us the status for that. So while this is happening, does anybody have any questions?
What happens to MySQL during this process? Is that pod still running?
Yeah, on the source, it's still running.
But
so
the way it works,
the way it works from the storage side is we actually take a snapshot of the PVC and then start migrating the data. So there's an application consistent snapshot that basically gets migrated.
Very cool.
Yeah. Yep. So as you can see, basically the volumes got migrated, and we basically migrated 4 resources. And as you can see on the other side, it just started spinning up over here, and the pod is actually in running state right now. So this migrates everything. It migrates deployments, stateful sets, config maps, secrets, PVCs, and all the stuff. So you can basically take your application from one cluster and just put it on the other cluster.
Very, very cool.
Right. So let me just switch back to the presentation. Does anybody have any questions about the demo? Okay, I just have one more slide with what we are planning to do for the future. So for future improvements, we are basically working on an operator for a storage cluster. So that will we are basically planning to write a generic storage cluster CRD that can be used to deploy any storage solution on Kubernetes. So it'll have the most common options that all storage solutions would be able to use, and just plug in and deploy the storage solution. We are also planning to add an operator where you would be operator for object store, where you would just be able to specify what kind of object stores you want. And we are planning to start off with having a menu object store. So you would just in the CRD, all you would need to specify is a storage class. We would spin up deployment services and basically provide you with all the credentials for the object stores and the service endpoints and stuff like that. We are also planning to add an operator to basically back up all these resources to an object store. What I showed you was a live migration, so you need another cluster to be up and running to migrate your data, but we're also planning to have an operator where you can basically back up everything to an object store. Yep. And so a lot of this stuff is basically written, is abstracted out. So it's written so that people can actually add your own drivers, and there's basically an interface that you need to implement to have your own driver. For example, for the volume driver, there's an interface defined, and as long as you implement this interface, you'll be able to use any of the features from Stork.
All right.
Anybody's got any questions?
Yeah. Well, we're actually going to just keep kind of moving along here, and can ask questions in the chat because we have a couple other operators to hear from as well. Andre Tost is on the line. He's new to this group from IBM. So Andre, if you have slides, share them.
Yeah, can you hear me?
Yes, I can. Thank you.
All right, perfect. Sharing my screen. Yeah, so like you said, so first of all, this is Andre. I got a couple of my colleagues here in the room with me. And as you said, we're new to all this. We don't really have an operator to show off at this point. Maybe we can do that in a later meeting. So I guess I'm just going to spend a couple minutes explaining who we are, what we do, what our role is, and what we're working on, and see where that takes us. So we're a team within IBM. We're kind of a central team that is tasked to help all of our software products be containerized and be running and fully supporting Kubernetes. And we've primarily done that so far through the use of Helm Charge. And so we're a bit of, if you will, a Helm center of competence within IBM. We provide guidance and conventions and rules for all of our development teams, and there's many of them, as in what these charts look like and the criteria. We even have very similar, I guess, to what you're having with operators. We have a certification program that's internal at this point, where before they can ship, they need to go through our process to get certified and essentially get our stamp of approvals. So again, very, very Helm-centric. Now it's kind of, and I keep telling everyone that's what we're going to do this year. We're going to do a transition and a shift towards from going Helm-based to being operator-based, which is why everything that's being discussed here and everything you guys showed is extremely interesting to us. And it's kind of like the only picture I want to show here, I guess, is that's one that we've been taking around also internally to kind of explain to people what we want to do to get from what I essentially think of as a fire and forget kind of process that you get with Helm, where you say Helm install and then it goes off and creates a whole bunch of resources, but then you're kind of left on your own to then maintain those resources and make changes and so forth, as opposed to the operator model, which is more of a desired target state management kind of model that's more autonomous and automatic and go through there, which then will also allow us to do more of what we call day two operations. And many of the examples you guys showed earlier on this call were good examples for that, you know, where you want to move things around or change what they look like or scale or whatever, and have first class kind of objects that represent that, and have implementations for those, which is something we don't have today. We're primarily worried about the initial install and config, and like I said, Helm has been serving us pretty well. So what we plan to do is, and we've done a lot of prototyping, so we've written a couple of operators and so forth. We haven't created any yet that we would consider kind of commercial grade, so to speak, because keep in mind the things that we represent, or I didn't mention, to date we have a little over 100 Hound Charge that we essentially have as product offerings, fully supported, that sit on top of our commercial software offerings. And so we need to bring all of those 100 over to kind of the operator world. And we want to do that in a way that is what we call enterprise grade. So what we plan to do is use the operator SDK. We probably want to start out with letting people reuse their Hound Charge, because we do have a lot of investment in that, and use that kind of as the source to then generate, at the very least, a skeleton from those Hound Charts as a starting point. I think we're having a lot of discussions also about what's the right modeling, what is the right level of CRD? Can we develop kind of a common taxonomy there that would be consistent across all of our products and so forth? And there again, I love to see the examples that you've shown up here earlier, because I mean, at least at a high level, they're all aligned with what we've been thinking in terms of what they need to look like and the granularity of them. So that's all good news for us, I guess. And I have a feeling that some kind of best practice for CRD modeling, if you will, is kind of emerging there. And we have it as a job, like I said, to work with those teams. We're not going to create the operators for them. They have to do that. But we want to provide help and assistance and guidance and skills, if you will. So one of the things we do is we write it all down in cookbooks and other things that they can then use. We also definitely plan to do all of these operators kind of in the open community. So we want to have them publicly available. One, I don't know if I could call that a difference. One thing to keep in mind, though, is that many or most of our stuff is commercial software that is licensed, that is not available for free download. So the images that sit behind these operators, I mean, that contain the actual software products, they're going to need to live in, you know, let's call it protected registries, so to speak, because we need to have some entitlement checking in there and all that. That doesn't necessarily mean the operators can't be in the open. And we were just having a chat here earlier saying that I would like for all of the operator code that we're building to be open. There's really no need for us to keep that internal, because we want to share that and basically collaborate with the community on how to bring that forward. Another interesting point maybe to this, and that's going to be my last comment, is one thing that I feel is a bit of a gap that we have in our Kubernetes platforms right now. And we have products, we have something called IBM Cloud Private, which is, think of it as similar to what OpenShift is. We have a managed service in our cloud as well. And obviously the goal is to support all kinds of Kubernetes flavors, including the Amazon and Azure flavors and what have you. One of the problems, or one of the gaps that I feel we have, is that we're fairly good at, on the one hand, saying, here's a piece of software, we can bring this up and manage it through automation, like Helm today, maybe operators tomorrow. We then have the other side of the coin, which is now someone wants to go and create an application that runs on this platform, a cloud native application using microservices and so forth. I think where we're having a bit of a gap to address is how you bring those two worlds together. How is it now really easy for my application to plug into an operator-based piece of software a service that I then want to use. And what we've explored there, and we've had some good successes there, is to use the open service broker model. And that's what you see, if you will, in my slide here at the bottom left, so to speak, is that one of the things we want to have come out of the operator, if you will, is endpoint and credential information in the form of bindings, and OSB standardizes those, that we can then easily plug into a consuming application so that it can connect. And there again, and I think we've had a conversation with Rob about this a few weeks ago, and his comment at the time was, well, there's not a lot of traction for OSB at this point. I don't know if that's necessarily true. I mean, in principle, conceptually, though, what that basically means is we need to have specific CRDs that reflect bindings that an application would then use, which we can then automate. And whether we stuff those into a service binding or in something else, that's a different question. But I think, to me, that's an important aspect of, as we're modeling these CRDs, and ultimately that's going to lead to, again, maybe a certain taxonomy that we can define, is that there's topology-centric CRDs that represent clusters of things that then run a service, and then maybe day two operational types of CRDs that do things like backup or migrate or upgrade, but then also have application-facing CRDs, for lack of a better term, is where I can consume things from this backend and have the bindings that go along with that. That to me is an important aspect that we want to do. So we're really at the very starting point of now where we're sitting here every day saying, how are we going to roll this out to the masses, so to speak, at least within IBM? And we're about to get rolling on that and hopefully have the first set of operators coming out real soon here. As far as where we stand within IBM overall, we have bits and pieces where people have created operators. The best one is probably from the cloud database team. They're already using operators today as a first-class thing, and that's a really, really good reference point for us to build on top of. But they're really the only team that I'm aware of right now within our company that is fully embracing this model. So there again, the task at hand for us is that it goes with a bit of evangelizing and socializing as well, to kind of spread the word and saying, and here's how you guys should do this.
Is that one from the Cloud DB, is that in GitHub anywhere?
That's a good question. I don't believe so. I think they're just using that internally. And in fact, that was also part of the conversation we had with Rob, where Rob was advertising to put it also on the operator hub. I have to admit that I'm not quite sure where that's at right now.
If you could track that down, that would be great. And we'll help them do whatever they need to if it is something that they can put out in the public. That would be wonderful. Okay.
Our Helm Charge, like I said earlier, that's what we're using today. They're all in public GitHub. We have a repo there where we host all of those.
I posted a link in the chat to the briefing that we did yesterday on was a deep dive on creating Helm operators.
Okay.
I think I did it in the context of a tweet. But there'll be a blog that comes out early next week as well with the video embedded. But it might be something y'all want to take a look at. Rob
definitely, yeah.
Great.
Like I said, we cannot really, at this point, we cannot go around and say, throw away your Helm chart and start over with operators. We need to find a way to evolve from one to the other. And I think that will be at least a very good starting point for us.
I think that we're well aware of that, and we don't want you to throw away your Helm charts. So there's definitely a path forward. I don't know, Rob, if you want to say anything or just make them watch the video. Did a lot yesterday.
Yeah, you can watch the video, and I think we've had some conversations about this as well. But I think you probably have some extremely complex Helm charts from some of the ones that I've seen. So it'll be interesting to stress test our Helm SDK and see if that handles all those.
Yep. We just had this exchange. My colleague Joey, sitting right next to me, he posted a question about Helm hooks, for example, which is something we extensively use. And there was a reply right away. I forgot who replied, but said, oh, try this out. If it doesn't work, let me know because we got to fix it. And that's exactly the stuff that we're looking for.
Awesome. Any other questions for Andre and his team?
I'll just throw out a comment that I think this group is the group that I think it would be great to, if as you model your CRDs and you're coming up with kind of the rules that you're going to give to all of your teams, I think we'd love to kind of share those and craft them as a group, because I think everybody is going to tackle that same problem, basically.
Yeah, absolutely. Good point.
Get some of that up on the docs too for operatorhub.io and other places in the operator doc. That would be great. People can not reinvent the wheel each time.
Yep.
Perfect. So I think Zak is with us. Zak Hassan from Red Hat, who has been working on the MLFlow operator. You there, Zak?
Yes, I am.
All right. You want to share your screen and we'll walk through that too. We're getting close to crunch time, but we got 15 minutes left.
Cool. So I did a full-on presentation before on all about MLFlow and machine learning and experiment tracking. But I'm gonna give like a quick demo on some of the new things that we're doing with MLFlow, and then what I'm gonna be doing in terms of porting this over to the operator hub. So real quick, MLFlow is an operator. MLFlow operator is for experiment tracking for machine learning. Basically, it's deployable into into OpenShift, just like how you normally do it with cluster service version. And when you click, you can launch an instance. You give it a name, Zak tracking local. We can do that. And then we'll have the Zak tracking local here. So this tracking server is just basically going to be tracking your models. So I have a little bit more of an interesting demo. So the demo that I'm going to show you today is going to be running multiple machine learning jobs and tracking different parameters, and getting back different metrics and comparing. So Argo is another tool that I'm using to do this, but basically MLFlow is going to be tracking all the information. So if I run Argo, it'll go through some steps. So this is the workflow. It's running some steps, and basically after this is done, we're going to have our model and the parameters that were used to train that model, and the metrics that came back from it. So I had 18 experiments before. Now if I refresh, I have 27. So if I compare, I can compare 1, 2, and 3 side by side and say, okay, which machine learning model do I want to go with in terms of hyperparameters? So why am I tracking these parameters? This is hyperparameter tuning. This is a technique to optimize your machine learning job. So you can pick the optimal parameters to train your model, and then you track the metrics and compare which metrics give you the best metrics, and then you choose that model that you want to roll out based on getting back the best metrics. So more details on the Golang stuff. MLFlow tracking. Yeah, so the code is here. It's going to be moved to the MLFlow community, and it's going to be contributed up there. There's just some slight things that I'm thinking about. So I was asked to remove the vendors directory from instead of contributing like this whole big repo. I would have to delete this vendor directory, and I can regenerate that. So I do have some questions there's a log file. I think I think it's safe to delete that one, right?
Who's a Go expert?
Yeah.
Yeah. Okay. So yeah, basically, as long as I can delete some of these things, it's good if I can delete some of that and the vendor directory, so we don't have to check it in. So other than that, so MLFlow currently, the operator, what it supports right now is it's able to store models, machine learning models in Ceph storage through the S3 protocol. And the way that I do that is I actually use a secret. So, for example, this is one of my secrets. So this secret needs these particular parameters: the AWS secret key, the secret access key, and the ID, and it also needs the endpoint. If you're not using AWS, you would provide this particular parameter in your secret file. And then once you create this, what my operator does is it will go into, let me show you the Golang code. It will go into it would go in and mount that secret. So if you specify the secret, it'll go in and it'll mount that secret into your container and into that tracking server, into that environment, and then I'll pick it up and then I'll make sure that the tracking server can connect to Ceph and store the models there and all the experiment metadata. That's pretty much it. I wasn't expecting to do a very long demo, or this was a quick one.
Can you give us an update on, I know you were working with the MLFlow repo project folks. Have you got and you had a pull request in to move this from your personal repo over into the MLFlow one? Is that happening anytime soon?
It's already happening, and we're engaged in discussing like some of those things that I mentioned earlier, like deleting the vendor directory and any extra files that don't need to be there. There's some files that they had questions about, which is there's these what's it called? There's these files that get generated. So if there's any, like if I can delete some of those extra files, then it'll make the process a little bit quicker.
So Rob, maybe we need to take a look at that again and give him some coaching on that.
Yep. Happy to help.
All right. So let's see. I think we've worked through most of the people we planned on having initially on here, but we have been hearing quite a bit on the mailing list from Marc Boorshtein from Tremolo Security about his JavaScript operator. So I thought I'd ask him just to give a little bit of feedback today on that. So Marc, if you're unmutable or immutable.
Hey. Can everybody hear me?
Yes, we can.
Okay, cool. So I don't really have a presentation. Can folks see my screen?
Coming. Yep.
So what we're doing is a little bit different. So we are creating an operator. So as a little bit of background, Tremolo Security, we're an open source identity management company. We have customers that use us to manage authentication, authorization into their OpenShift and Kubernetes clusters, different types of infrastructure, all the way up to public safety, and phone needs to go off. Public safety applications. One of the largest suburban jurisdictions in America uses us to register and authenticate their taxpayers and folks using their court system. So we're both infrastructure and we're application. And we're also integration. So we need to be very, very flexible in the way that we approach our operators. And so we kind of started off, how how do we go ahead and we automate our deployment? Our application is when all is said and done, Java web app. Does lots of different things, but it's a Java web app. So on its face, that would seem like it's pretty easy to containerize, which it was, but building a system that let us make it easy to deploy was astoundingly difficult because of how flexible we had to be in how many situations. So when we started our automation journey about a year ago, a member of our community had put together a quick start or a documentation on our quick start for Kubernetes, integrating it with SAML, and it was like 30 pages long. It wasn't incredibly difficult, but it was run this key tool command, run that key tool command, get this cert sign, get that cert sign, pull this out of metadata. And so we realized we needed to make that easier. So our first attempt was with Ansible playbooks. We had written a playbook that would let us deploy our OpenShift variant via playbook directly into OpenShift. So it would create all the key stores, create all the secrets, everything. And the idea was, you can see here, your input would be something like this, where it would just be a set of parameters, and we would figure out everything else. And we ran into problems with that. We've got a lot of customers that use Ansible. When we're deploying onto VMs, often our first thing is say, well, here's a playbook that we use that works real well. But the biggest issues we really ran into were lack of PKCS12 support outside of OpenSSL was a big one. OpenSSL only supports one key per bundle, and Java, we need to be able to store all sorts of different keys. And so that was the first problem we ran into. The second problem was we had to do a lot of XML parsing and transformation. Anybody who's familiar with SAML2 metadata knows the pain we go through. And Ansible actually had a lot of, had different implementations for that, depending on whether it was on Fedora or CentOS or RHEL. So it was a good first crack, it worked, but it wasn't really maintainable. And so then we built we took the lessons learned from that, and we built this idea of a installer. We didn't want to rely on Helm charts because we had feedback from customers that said, we actually kind of want to install the identity management solution for our Kubernetes infrastructure before we do Helm. We want to track who has access to what. And so we didn't want to make Helm a dependency. So we built a deployer, and we started working with Java. We're a Java shop, and Java JSON support is terrible. I mean, it's horrid. There are words for it that aren't appropriate for public use. And so we looked at it and said, well, JavaScript has native JSON support. I can run JavaScript on Java. Why don't we create this in JavaScript, run it on Java? So we built the installer, worked great. And then these things called operators come along. And some of the tools that we need, things that we need to be able to do were things like we said, generate the key store, get keys signed or certificates signed by a CA, whether it's the certificate authority inside of Kubernetes if it's available, or customers who are using Vault or EasyRSA, which a lot of the distros will do, get those certs signed there. So provide hooks for that. And then we also were doing things with like interacting with the dashboard because we provide SSO there. So what's interesting about it is in a lot of ways we're much simpler than a lot of the apps that you're going to see in operatorhub.io because we are in essence a stateless Java application, but we're more complex because I can't say you have to use MySQL, you have to use PGSQL. We've got customers on SQL Server. We got customers on Oracle, stuff that we can't distribute. So we can't just create a stack binary of jars. And so that's where the idea behind the JavaScript operator framework came in. And what we wanted to be able to do is say, okay, we're going to create a framework that lets us use all of our libraries that we've built over the years for interacting with Kubernetes, interacting with key stores, and make that as an option. We're not Go programmers. Nothing against Go. It's just not what we do. We've built a large infrastructure around Java. Most of our customers are very comfortable with Java. And so seeing Java and JavaScript is something that they're familiar with as well. We looked at Ansible. We thought about going with the Ansible one because we are very comfortable with Ansible. But that would have required a pretty hefty investment in building out better support for PKCS12. And we could have done that, and we would have been happy to donate that. But for us to be able to get to deployment and get to customers that are actually, or get customers our software, we saw this as the fastest way to doing that. And so the idea behind the framework is pretty simple. We don't do a lot of the stuff that the operator SDK does. We don't do code generation. We don't do the CSV generation, anything like that. It's really straightforward. You implement JavaScript files like you'll see here on my screen, and you provide an on-watch event, and we're just going to give you the raw data. At that point, you then can do whatever you like with it. So for us, we need to go through, generate a secret, generate a Java key store based on the information. Some of the things that we ran into were like, how do we handle secrets, right? Do we store it in the CRD? That is like a terrible idea, to be honest, from a security standpoint. Not that secrets are really handled that much better than any other data, but at least I'm hoping sometime in the future that there will be better support for externalizing that out of the box transparently. So we want to stick with the idea of making sure that you're using secrets. For really sensitive information. We're an identity management system, so we might have administrative credentials for your Active Directory. That's not something that you want to store in a CRD. So we want something that made it easy to interact with different types of objects, not just our CRD. Some of the other things we ran into were like, how do we handle handle error handling with Kubernetes API at a low level? We ran into issues with like when we built out our custom resource, how do we not make it too crazy to be able to reference different fields so you don't have to do the same thing once or write the same thing more than once. So we actually ended up using utilities for like being able to embed small JavaScript snippets into the custom resource. That made it a lot easier. So the operator itself is pretty straightforward. If you go to GitHub, here's the site for it. It's still really really early. I would call this a prototype stage. There's a lot of error handling in there, but it gives you a basic idea of if you want to get started, what to write. You can take a look at. We have written a prototype operator for our software using it, so we're using that as kind of the example. It's not really ready for prime time and ready for display yet, but the code there should give you an idea as to kind of how that came together, and how you build it, how you run it, how you build a container out of it.
So what's the status? What's the status now of it? Is it something that you're going to be putting it in Operator Hub? This sounds more like something that you guys are going to be using internally rather than. Tell me a little bit about what the roadmap is.
So it is an internal tool. We built it mainly for us, for our operator. But we're an open source company. We do just about everything open source first. So really what we wanted to do was just put it out there. PRs are welcome, suggestions are welcome. This has been a bit of a journey for us, kind of learning the ins and outs of how these things are supposed to work. And so, if other folks want to use it, other folks want to make contributions, that's awesome. This is not a product we're building. We're not going to build like a commercial version and sell this. This is primarily so that we can get a faster, more manageable to market for our own particular situation, for our operator. So what will end up in Operator Hub is the Open Unison operator that we're building on top of this.
Right. We'll look forward to that. We've run over time a little bit today, so I just want to respect everybody's time. A lot of people are hanging out and still hearing this. And I know Rob has to pop onto another call. So I'll let you go. If other people have operators that they want to get some airtime for, the next meeting is the third Friday in April. If you want to go longer and talk about, maybe Portworx, you wanted to do something a little bit longer, and talk about your actual product offering and projects, please let me know and I'll schedule a briefing. And again, there's a healthy conversation on the Google group, so I would strongly suggest that you either join, or you definitely join the Google group, the Google framework, operator framework, or pop over into Kubernetes. And the Kubernetes operator Slack channel is pretty active too if you have questions. And I'm trying to think, anything else I should be adding, Rob, there?
Yeah, I think that about covers it. I just wanted to mention that the app binding proposal that I had on the agenda, we can punt until next time, but I think that's, the topic that the IBM folks were bringing up. And, as all these operators work together, we want to have this great, rich binding experience. So maybe some homework for everybody is to go read through that proposal and come back with your thoughts for next time.
Post that to the group too, so people can find it and ask for their opinions. All right, everybody, thank you very much. Happy Friday, and wherever you are, have a great weekend.
Okay, thanks everyone.
Thank you. Bye.